All right, let's talk about something that trips up pretty much everyone in stats at some point. You've got data from two different groups and you need to compare them. But which test to use? It can be a real headache, right? Well, today we're going to clear that up for good. So, you've done all the hard work, you've collected your data, and now you're staring at this alphabet soup of statistical tests. Z-test, T-test, F-test. They all sound kind of the same, and if you pick the wrong one, your whole analysis could be off. It's, a classic roadblock.
And yeah, it absolutely feels like you're stuck in a maze, just trying to find the right path forward. But what if I told you there's a simple, clear map? A map that's going to guide you to the right choice every single time. No more guesswork. See, the secret isn't about memorizing a ton of different rules. It's all about using this really powerful but super simple two-step framework that just cuts right through all the confusion.
That's it. I'm serious. Just two questions. First, what are you actually comparing? Is it percentages, averages, something else? We call that the parameter. And second, how are your two groups of data related? Are they totally separate or are they connected in some way? You answer those two questions and you are golden.
So let's dive into that first big question. What is your parameter? This is really about getting to the heart of what you want to know from your data. First up, we've got the proportion, which we note with the letter P. This is your go-to for anything that's about percentages or rates. Think categorical data. So stuff you can sort into buckets, like yes or no, pass or fail, voted or didn't vote. If that's your data, you're looking at proportions. Next up is the mean. You'll see it as the Greek letter mu, and this is the one you probably know best. It's just the good old average. So if your question is something like, is the average test score in Class A different from Class B? Or is the average height of one plant species different from another? Well, then the mean is your parameter.
And our third option is the standard deviation, or sigma. Now, this one's a little different. You use this when you don't really care about the average, you care about the consistency of the data, the spread. So, for example, does one manufacturing machine produce parts with way more consistent sizing than another one? That's a question about variability, and that means your parameter is the standard deviation.
Okay, great. Once you've figured out your parameter, you are halfway there. Now we just have one more question to answer. Are your samples dependent or are they independent? This sounds tricky, but it's pretty straightforward. Dependent samples are linked. They're matched pairs. The best example is a before and after study. You're measuring the same person or thing twice, so that before score is directly tied to that after score. Independent samples are just what they sound like. Two completely separate, unrelated groups. Think a control group versus an experimental group. The people in one group have absolutely nothing to do with the people in the other.
And that's it. You've got your parameter, you know your sample type. Now for the fun part, the payoff. We can put those two answers together to find the exact correct statistical test to use.
This table right here, this is your map. It lays it all out. Are you comparing proportions? Boom, you use a z-test. Are you comparing means? Well, now you ask that second question. Are the samples dependent? Then you use a matched pairs t-test. Are they independent? You use a two-sample t-test. And finally, if you're comparing that variability, that spread, your tool is the f-test. See? No more guessing. It's just a logical path.
So let's just peek at the tools themselves. For comparing two proportions, you use the z-test. Now don't let the formula intimidate you. All it's really doing is comparing the difference you see between your two samples up top to the amount of difference you'd expect to see just by chance on the bottom. It just tells you if your difference is a big deal.
For those dependent means, those matched pairs, you're going to use the matched pairs t-test. The key here is that D bar on top. That's just the average of the differences between your pairs. So, the formula basically asks, is that average difference big enough to matter when you account for its variability? And for those two separate independent groups, it's the two-sample t-test. Again, look at the top. You're just taking the average of the first group and subtracting the average of the second group. The whole bottom part is just a fancy way of accounting for the sample sizes and the spread within each group to see if that difference up top is actually meaningful. And last but not least, when you're comparing variability, you use the f-test. And this formula is super simple. It's just a ratio of the two variances. That's just standard deviation squared. If the variances are similar, that number is going to be close to 1. If it's far from 1, then you know one group is way more spread out than the other.
So if you remember anything, remember this. Don't get lost in the formulas. Don't worry about memorizing the names. Just come back to these two simple questions. 1. What are you comparing? Proportions, means, or standard deviations? And 2. Are your samples dependent or independent? That's it. That is your map out of the statistical maze.
Because here's the cool part. Once you can confidently pick the right tool for the job, everything changes. The whole focus shifts from the confusing "how do I do this?" to the exciting "what can I find out?" You're not just trying to get through a homework problem anymore. You can actually use data to answer real, interesting questions. So now that you have the map, what are you going to go discover?